So, welcome to the breakout session on living games, where we will discuss generative AI and how we can integrate generative AI in games on the cloud. First of all, I would like to thank Unity for inviting us to speak. Really appreciate. I do have some of my colleagues speaking as well. Matthew in the audience will be giving a session later today at 4:30 on stage 5, so definitely check that out. He will expand on some of the concepts that I will be covering today on just briefly referencing on running live games in the cloud. So shout out to that, please do attend it. All right, with that, let's get started. So a little bit about me. I'm Ishan Sharma. I'm a senior product manager in Google Cloud. I work within the Google Kubernetes Engine team. I lead the team that's focused on games in cloud, on Google Cloud. And really my passion for that is building one of the best platforms for you to be able to run and serve your game workloads. Another part of my role is AI infrastructure on GKE. And for that, I am really excited about bringing AI ML to the cloud and especially to games. When I'm not working on technology, I love hiking, running, biking. I live in Sunnyvale in California, so the weather is usually beautiful, so I try to enjoy the outdoors. And when I'm not doing all of that, I'm teaching meditation. So today, there are more people playing games than ever before. And most of them are playing and paying through live service games. Now, live service games are not the future of the games industry. In fact, today, live service games are the games industry. And top grossing games on mobile, PC are live service games, and consoles are not far behind. Now, in a recent survey of over 500 game studios, 95% said that they were working on a live service game. Astounding, isn't it? Now, this doesn't mean that they're going all in with content drops and daily subscriptions and all of those. It's really that game developers realize that they need to update and evolve their games with their audiences. And that's the reason why so many games are adopting some form of live service. Now, if you think about it, Google has been building live services for years. This is really who we are. It's really deeply embedded in our DNA. Now, with the introduction of search back in 1995, Google has really built a strong foundation for reaching billions and billions of users across the globe with some of our live services. And we offer a diverse array of experiences with some of our products that encourage growth, all because of solid technology foundations that we have built. And it's not really what we have built in the last few months or last few quarters. It's really what we have built over the last 15 to 20 years that we can share with you as part of the technology platform. Now, launching and operating live games, as you all know, requires a whole new mindset. It changes the thinking for design, production, and of course, the technology that underpins it. This is where Google Cloud can help. We help game developers maximize their odds by helping them connect with players and scale their businesses. Google Cloud provides fast, performant infrastructure for game servers. That's sort of our first pillar. That stimulates and delivers immersive virtual experiences. The second pillar is about databases. And databases are absolutely critical for live services because they help you record player behavior and record any progress that's made in the game and then build upon it. And finally, the third pillar is understanding the insights, the analytics. For each of these three pillars, for game servers, we have Google Kubernetes Engine. For massively scaled databases, we have Cloud Spanner. And for analytics, we have BigQuery. What we believe in Google Cloud is providing you, the game developers, an ecosystem for running live service games that helps provide exceptional player experiences by unifying performance and insights. We're proud to report that 10 of 10 top grossing game companies in the world now use Google Cloud for at least some of their live service workloads. And our technology and solutions have been built for live online games and platforms. And as a result, we have seen adoption of Google Cloud in the games industry accelerate at an alarming pace. Here are some game titles. And we're proud to say that we have had a hand in helping launch some of the biggest live service games. And these are just a few of them, all released in the last year and a bit. I think you'll recognize a few of them. Now, here's a video where our customers show, or a couple of videos where our customers tell you how they have used Google Cloud.
私たちが本当に提供したいのは面白さ。その面白さにかけられる時間っていうのをとにかく増やしたい。インフラの低レイヤーなオペレーショナルなところは、マネージドされればされるほどいいと。マネージドサービスそれぞれを組み合わせていかに、ストリートファイター6のコンセプトを実現させるかできるか。そこで、最適な選択だったのが Google クラウドです。
一番大きかったのは、Google クラウドスパナという、データベースのサービスで世界展開しなければいけない大量のトラフィックをさばかなければいけないという、こちらの利用条件に、マッチしたものであったので、選択の決め手となりました。ストリートファイター6は割とそのゼロベースで構築しようっていうところもあって最先端に近い、技術選定をしているところもありまして検索してもあんまり解決方法が出てこなかったりとかサービスを実際に作っているエンジニアの方とかと直接つないでいただく機会も、ございまして、問題解決というのは比較的スムーズにいったかなと思っております。
バトルハブって申し上げたような仮想空間での、ユーザー同士のコミュニケーションですね。アバター同士で、戦うなんていうこともできます。この部分においても、かなりスムーズに皆さんプレイしていただけていることが我々も実際に入っていくと見れるので、ここはGoogle クラウドを採用してよかったなと考えています。Google クラウドは世界中に当然リージョンがありますしそれぞれの、海を越えたネットワーク品質も、素晴らしいと、さらに、Google クラウド内の、つながりやすさ速さも申し分なかったのでまさにプラネットスケールと言えるのかなと考えています。
Just last week, we released another video with a game developer you will recognize.
Game on. Every second of every day, people play our game. There's never a time when there's no one playing our game. My name is Ishan Chen. I'm a senior principal architect at Electronic Arts. Electronic Arts is a developer and publisher for video game contents. We exist to inspire the world to play by connecting users to gaming content around the world. EA Sports FC is a soccer video game that connects many different types of users. This is like the biggest title we have in our company. At peak times, we see millions of users basically engaging in our game at the same time. We took all our compute capacity, including application, databases, tools, and other things from our on-premise data center, and we moved all of those into Google Cloud. Well, we wanted to get out of the migration a couple of things. So one is more elastic infrastructure, so we can scale up and down. The second one is we wanted to find opportunities to automate more of what we do so that we don't have to spend all this time maintaining infrastructure, but rather trying to spend more time innovating on our services instead. We want to make a transformative change to our database to something like Cloud Spanner. There's a lot of work we do today where we try to maintain our scale, and every time we need to scale up and go bigger, it's a lot of effort. We want to leverage someone else's expertise so we can focus on running our business rather than scaling our databases. Within Google, they are all very much want to go the extra mile to help us on our journey. We have been able to effectively move faster and be more agile than we have ever been able to do before. So this has been great. We have been able to spend more time trying to figure out what are the new things we can do. Electronic Arts is innovating new ways to connect users to inspire the world to play.
It's nothing like customers telling you why they chose a particular platform. We're really excited to continue our partnership with Electronic Arts. It's a truly humbling and learning experience. Now, here's the reality though. With live service games, both players and developers are really immersed in today's live games. What that has resulted in, however, is that majority of the players are still stuck playing games, the same games year over year, because they're engaged. Now, what that does is this behavior creates an ecosystem that is difficult to capitalize on new audience and gain market share, right? So with majority of the games competing for just 40% or 39% of playtime, it creates an important moment for developers to focus on how we can create more incredible games. This is a statistic from Newzoo, which says that in 2023, 61% of time spent in games was on games that came out 6 or more years ago. So really, majority of the audience aren't consuming the new content. It's very difficult. You know, in addition to that, in addition to going against that statistic, it's difficult also because there are other underlying forces that are also in play. And perhaps these will resonate with some of you. There's a huge technical debt that a lot of studios are faced with. 53% of large studios expect to struggle with managing their technical debt. The second aspect is the overall playtime of games is declining. It's down 26% quarter over quarter from Q1 2021 through Q4 of 2023. And game development costs are ever increasing. 77% of studios report that game development costs are continuing to rise as they try to keep up with these trends. And AI is driving a games revolution, where 50% of the game studios say that in the next 5 to 10 years, they're going to integrate AI in one way or another. And that's really where the solution is. That's kind of where I'm leading. That not only do studios need to excite their audience by developing new features and experiences, but studios trying to keep up with this demand have to take something else. There has to be a silver bullet, perhaps, somewhere. Now, AI is not that silver bullet, but it is a step in that direction. And what I'm going to talk about in the next few slides is how we have learned studios are using AI and integrating them in their games to improve player experiences. Now let's take a step back in time. Back in the day, there were boxed games. I'm from the US, so every Thanksgiving or Christmas, I would stand in line at GameStop or Best Buy to get the latest game title. That was an era where developers built games and they shipped them. They could control the prices, they could control the supply, and it was a one-way street. Then came the era of live games, where there was this link between the developer, or the cycle between the developer and the player. Developers could add in content drops. Developers could create in-game economies. This is where we are today, and it creates more immersive experiences for the players. And now we're ushering in a new era of what we have coined is our living games. And living games are where there is that cycle, of course, between the developer and the player, but now there is a component in the game itself where it's adapting to the needs of the player and creating even more immersive game experiences. And that's where AI or generative AI starts to come into play. And generative AI really started with the launch of ChatGPT. That's where it became a household name. Of course, companies like Google have been working with AI for many years now. But as ChatGPT was launched, Bard, Gemini, etc., the term generative AI became mainstream and a household name. And machine learning and artificial intelligence is continually being improved over the last decade by a lot of researchers, scientists, and now industries. And generative AI, which is a type of artificial intelligence, as most of you know, it can produce new text, new images, new videos, new audio clips, and that's part of their evolution. And what that means is it can create new experiences for players. And just how generative AI is transforming how we interact with technology, it allows games to change how players interact with the games themselves. So this is a chart that I'd shown you earlier, where at Google Cloud, we believe in an ecosystem of live service games that is based on 3 tenets: game servers on GKE, databases on Spanner, and analytics on BigQuery. But ushering ourselves into the new generation of living games, we have modified this chart slightly to add in realizing living games with generative AI across all of these pillars. But to start off with, there are some considerations for AI in games. We start with there's a lot of content here, but if we start with just the platform, there's cost. How do we deal with cost? Operating at scale. That can get very expensive very quickly. Or latency. Games are very sensitive, as we all know, to latency. A lot of times games require millisecond latency. So how can you integrate generative AI to run and generate output that quickly that you can integrate into the game? Platform selection. A lot of game companies don't like vendor lock-in. How do you create open technology that can really work with that? And then there's the whole aspect about AI maturity. There are concerns around how mature are models to really run in a live game. Are they ready yet? How do we avoid bias? How do we filter content? And the other side of filtering content is if a game does have violence in it, how do we make sure that the models are not filtering content and providing a worse experience than what might have been there? And then there's gameplay. Creativity, games having endless worlds versus boundaries of gameplay. There is a game lore to it. How do you ensure that the game isn't going off in a different direction? Or Gen AI model constraints or procedural generation. All of these are concerns that are very real today. However, what we have learned in speaking with a lot of game companies is that's not slowing them down. Game companies are starting to adopt generative AI or AI ML in very small baby steps to get to that final result. When we look at the variety of generative AI use cases in games, we can categorize them into 2 categories. The first one is improving productivity during game development, and the second is improving player experiences during gameplay. Think of it as offline in the studio as being the category which helps improve developer productivity, and the other one being during gameplay in real time while a game is being played. Now, what are some of talking about the first one, scaling game development teams with generative AI. This impacts everyone that is involved in the game development lifecycle, from engineers to artists to game developers to marketing. The key idea here is to accelerate the time to market and to help provide inspiration, ideation, plot ideas to help developers bug code. We believe that generative AI can be adapted as a tool that can help with productivity. For that, 2D, 3D asset generation is an example use case, audio and video generation, code generation, or AI-based game testing. For that, our flagship product in generative AI, Vertex AI, is a great tool. And here is why. Vertex AI opens up to you 130 plus models from Google, open source, and partners to help you run your generative AI applications. From Google, we have Gemini, Imagen, etc. And then, of course, we have open models that we also support, all available in one place called the Model Garden. Additionally, with our Hugging Face integration, you can have access to over 100,000 models that you can use through Google Cloud Vertex AI. And with aspects like Gemini's Code Assist technology, developers can really improve their time to market by using Vertex AI and Gemini Code Assist as a tool to be able to really reduce the time to market. Vertex AI, taking a step back actually, generative AI can be daunting. There's so many options out there. Every week, there's so many models being released. How do you get started? I find that Vertex AI provides a great place to get started. It is a fully managed platform that lets you work with traditional AI and also advance into generative AI. Most importantly, we're committed to protecting your privacy. We're not using Vertex AI, we're not using those to train our own models. Your data is your data, and your privacy is extremely important to us. Now, moving to the second part of it, this is the exciting part about integrating generative AI into runtime. And for that, we believe Vertex AI and Google Kubernetes Engine are a great option to integrate generative AI into your workloads, into your game workloads. Some examples for this use case category are smart NPCs, dynamic in-game content, customizing player experiences, user-generated content, and ultimately endless worlds. Now, I've given you a variety of use cases. How many of you have actually explored some of these, either in improving development? How many of you, show of hands, have explored some of those use cases for improving developer productivity? Great. And how many of you have started thinking about integrating generative AI into your games? More of the runtime use case. Yeah. And how many have been able to do that successfully? Yeah, we're still working on it. So a lot of times, what we have found is through building demos and speaking with our customers, it's a tough problem to solve. But what I'm going to present to you is what we have learned working on demos internally, but also speaking with our customers. First off, I would like to start with Hybrid3D, is a Google Cloud customer, partnership between Hybrid3D, Google Cloud, and Datatonic. They've created a text-to-3D world creator, and this uses PaLM 2 underneath. So here's a video from Hybrid3D showing how that works. So as you saw, Hybrid3D used Google Cloud's, one of Google Cloud's foundation models, PaLM 2, to create a world creation engine that allows you to create these fantastic worlds with just some text, a few prompts, and a few simple clicks. Really fantastic. And there's the link to check it out at the bottom of the screen. But when we start to think about living games and integrating generative AI into your games in real time, We built out a few demos and we started to think about how we can do that. And this is an architecture where on sort of the left side, you have your classic live service games with your game servers running on, in this case, Google Kubernetes Engine, using Agonis as the game server orchestrator. On the left side, you have your players. Let's say it's a multiplayer game. Your players are directly connecting to your game servers that are preserving in-memory state using Agonis on GKE. You have a whole bunch of these game servers, which are really pods that are running on Kubernetes. Of course, Agonis is open source, Kubernetes is open source, so this is something that can be repeated across the board. Let's say you have your player metadata going down to a scalable database. In this case, we choose Cloud Spanner. Now, this is a classic live service games architecture, which actually Matthew is going to speak about more at 4:30 today. But then we start to think about how can we include generative AI in there? How can we integrate in there? And what we came up with is sort of this middle layer that connects the game servers and allows you to connect that with inference running either on some sort of a turnkey solutions, a fully managed solution, such as Vertex AI, where you might create your inference endpoint, or you can run your proprietary or open models on Kubernetes, containerize them, and run them on Kubernetes. Or you want to bring your own models or third-party partners or other inference endpoints that you might be running. What this middle layer does is it helps you load balance between these different options. And in addition to that, it lets you solve some of those pain points I addressed earlier. First, it lets you do content moderation. So let's say a user is, you're generating an image based on user prompts. Maybe you need to look at the prompts and do some sort of run a microservice that does filtering of those prompts so that you're not generating images that are not appropriate for the rating of your game. And then images go out to generative AI and they come back from the inference. And now you need to resize them. You need to process them, put on maybe a filter on top of them. All of those can be done in this middle layer. There are other aspects you can do. For example, you can batch some of the prompts and the inference that comes out of it, so that can help save costs. Text to speech, you can have a microservice for that. Or translation, have a microservice for that. So what this middle layer does is it takes in inputs from game servers that are running in real time with players running in players creating content or wanting to create content, takes in the inputs, gets through the middle layer processes it, and it goes out into a variety of different inference endpoints. And doing this allows you to really work and deliver generative AI in a way that is cost-effective, that is performant, and can handle any sort of content moderation needs that you might have. Now, if you're familiar with retrieval augmented generation, you can use the database such as Cloud Spanner to link back up that is already taking in metadata or game data from the game servers and enhance your experiences that are coming out. Why we chose Google Kubernetes Engine is because it really extends the platform that you use for live service games anyways, and extends that out to integrate in generative AI. And it provides a fantastic platform as one surface to be able to do all of that. Run your game server workloads, process them, and then run your inference serving. And Google Kubernetes Engine is or Kubernetes as a whole is a fantastic option for being able to bin pack your workloads. For game servers, you can bin pack your game servers, really use your underlying compute efficiently, but also be able to multiplex with containers that are running on GPUs. GPUs are expensive, they're capacity-wise, they're hard to get sometimes. So Google Kubernetes Engine really helps you, or Kubernetes in general helps you be able to bin pack and utilize your underlying platform really well. The second part of it is we celebrated 10 years of Kubernetes this year, which means that we have a decade of experience serving web workloads that can scale with user traffic. Something that's similar, if you think of inference as a web serving workload, just more powerful, it can scale up to the needs of your players. And finally, you can run it on Google Cloud without lock-in because it is based on Kubernetes, which is open source. In GKE, we have been investing in generative AI and AI ML overall. We have been improving our scalability. We have been improving our performance per dollar or efficiency for training, fine-tuning, and serving, and finally, our agility. We rely on a platform that is global, that runs on GPUs and TPUs, something that is unique to Google Cloud, and GKE can work on all of those. So it's a fantastic platform to integrate or get started with for your generative AI needs. When we think about training and serving your models, you might take an open model, you might want to fine-tune it, or you're training your own foundation model. Google Kubernetes Engine is a great platform which allows you to really scale out to your needs. We have industry-leading support for 15,000 nodes per cluster, and on TPUs with multi-slice configurations, we support more than 50,000 TPU chips to train a single ML model. So that's on the training and fine-tuning side. When you think about serving, our capabilities include 300 pods per second scheduling, container image streaming and preloading to really get your workload started so you don't have that built-up startup latency. And finally, advanced disruption management to ensure that we maximize the throughput or the good throughput, something that we call good put. So we wanted to try all of this out. Yes, we can put a reference architecture together and show it and say this is going to work. Who knows whether it's going to work or not, right? So what we did is we actually went out and we started to build demos. We have 2 demos that we have built. One shows Bragg with a smart NPC. And the second one, Guess the Sketch, actually shows real-time image generation that's happening within the game itself. So it tackles these scenarios, 2 different scenarios, shows you how you can generate images very quickly without having to wait a long time. It actually does give out a great performance for that game, for Guess the Sketch. But also for Smart NPC, we show you how you can really integrate it in a real environment. So those are available on this Git repo. Feel free to reach out afterwards as well. We'd be happy to share that with you. You can play around with it. The code base is available. And it's really to help you get started and see the architecture in architecture being run and used. Now, I want to leave you with just an overview, more of what can be done. The possibilities are really endless, and hopefully this will be an inspiration to you. In the second half of this video, we actually show you one of the demos that I just spoke about that is built using the same reference architecture that I shared with you. All of that gameplay is real. There is a smart NPC use case there. You will see the player interacting with a robot, and then you will also see image generation happening in real time. So what you saw there in the second half of the video was not scripted. When the player was speaking to the bodice, all that was provided to the bot was, it's based on an LLM, and all that was provided to the bot was just the game lore. And each of those conversations were different. So every single time you had that conversation, it wasn't some script that was written pre-scripted. It was a live conversation with an LLM, and a game lore was provided. So to bodice, it was something like you're in sort of this environment where you need to escape, etc. That was sort of the game lore that was provided. So all of those things, the responses would be different every single time, which keeps the player experience fresh. Now, you saw in that there was a point where the player changed the color of the bus. That was part of the gameplay. And that generation of the banana on the bus was actually an image that was generated in real time using generative AI. So that's just an example of how we can integrate generative AI into games with baby steps, one at a time. But the platform, which is what we're presenting to you, is getting ready for it. So using this architecture, as you think about integrating generative AI into real-time experiences into your game during runtime in the future, having this platform that's scalable really helps. And that's something we'd love to collaborate with you on and learn from you as you go down that path. Now, when you partner with Google for your next project, you're not just choosing Google Cloud. You have the access to the entire Google ecosystem, including Google Play, YouTube, all the way to Google Ads. And we really want to help you build, distribute, launch, and continue to grow your game. And that's really where we want to end with the mission statement for Google Cloud for Games. We're really here to power everlasting love for the game. Thank you so much for attending. It was a pleasure being able to speak here, and I hope that you will think about how you can use generative AI in your workflow to really enhance player experiences. And I hope you will think of partnering with Google Cloud. I'm here. Feel free to chat with me later on. And definitely a shout out to attend my colleague's session later on. Thank you so much.